Bismillahirrahmanirrahim. This is Sophia Suhail is here. Assalamu alaikum, my dear students. Hopefully, you're doing well. In my last video, I have explained already about the differentiation topic. Okay, what is the derivative called? And now I will explain about the power rule. The first rule for solving the or for taking the derivative, the first rule for taking the derivative, that is called the power rule, which is applicable almost in every part when you are doing the differentiation. So for that one, let's take a variable x with the power n. Okay, so I'm taking, let suppose a function f of x where x have an exponent n, where I'm taking n is a positive integer, positive integer. Okay, according to the differentiation definition or derivative definition, we have to find out the limit h approaches to 0, f of x plus h minus f of x over h. Okay, we have to find out this one relationship. When we apply the limit, that is equals to f bar of x, means f bar derivative of the function. For this one, we already have this one. Okay, so we have to find out f of x plus h. It will taking the form x plus h, the power stay at the same position. Using this formula, we will write down the value that f of x plus h minus f of x over h when limit h approaches to 0, if the limit exists, will be equals to limit h approaches to 0. Write down the value of f of x plus h from here, that is x plus h whole power n minus f of x value we will write down, that is x power n divided by h. Okay, solving it. For solving this one, we must know the binomial theorem, which is being applied if you don't know the value of the power, means any integer is in the exponent, any integer, means if square, you know how to open the square, means sum of two terms square, you know, sum of two terms cube, you know easily. But if the n power is not defined, that how much it is, so we are using the binomial theorem about that. For that one, we are using this one, that 1 plus x whole power n will be equals to 1 plus nx plus n minus 1 over 2 factorial and x second term square and plus continue this one. This we have to use. Okay, so for this one to apply, our first term should be 1. If we want to take it common, we can take common also, but which term is taken common? Here left 1 plus h. We have taken x as common. There was no x present. So mentally what we are doing, that we multiply and divide with x here. The term which is multiplied, it is taken common. The terms which is dividing, it will stay here. Okay, and power n here and power n on the same number which is taken common from the function, minus x power n. Our formation is done, but still before application of this theorem, we will try to take this xn common factor exactly outside. Limit h approaches to 0. When I am taking xn common, xn will come outside over h, and here left 1 plus h over x whole power n minus 1. Now on this one, I can apply this binomial series. Yes, apply this one. According to this one, it will taking the form limit h approaches to 0, xn over h first term plus power into first term h over x plus first term power minus 1 over 2 factorial. Here is 1 factorial is coming because 1 factorial is 1. 0 factorial also equals to 1. So we are not writing 0 factorial under this, 1 factorial here and 2 factorial. We have to write 2 factorial, okay? H over x whole square, and it will continue, okay? Now the first term is open and the last, this one, this minus 1 will be written over here. I will write minus 1 here, minus 1. So this plus 1 will be cancelled with the last minus 1. The terms which are left over here, we can write it in the form limit n approaches to 0 and then x power n over h over x plus n minus 1 over 2 factorial h over x whole square plus so on. The terms will continue according to the theorem. From all the terms now, h is present in all terms. We can take h common so that it can be cancelled with this h, okay? So we will do like that. Limit h approaches to 0, x power n over h, and I have taken one h common. Now this become n, and over x I am writing down, plus n minus 1 over 2 factorial. Out of the h square I take one h common, so h left still here, and x square separated now because the one h is outside but x, both x factors are staying here. So square on x, one h is taken outside. Now this and this can be cancelled. At this point, if we are applying the limit h0, the whole factor will be 0, and this 0 means 0 by 0 form is coming, which we have to avoid. Okay, now at this step when the h and h cancel, now check if we are applying the limit. So the first term is free of h, so it can be as it is, plus the next term as it is including h. After the application of the limit, this will be turning to 0, and remaining all the terms as they have h, so they all will turn to 0 also. Okay, now we will say that we can apply limit as the limit is existing now. So this part after application of the limit will change to f bar of x. This part after the application of limit will change to f bar of x. So I am writing this side as f bar of x if the limit exists, and this part will change to x power n and n over x. Now n I will write in the start, x power n, according to exponential laws, the x here in the denominator I can shift in the numerator. Its exponent is 1, so it will become minus 1 when it is shifting from the denominator to the numerator. Okay, so the sign of its exponent will be changed because it was 1. Now n, again according to the exponential laws, when the base of two numbers are same, their exponent can be combined together or added together. N and sum of n and sum of the other term, that is minus 1, it will be combined as n minus 1. So f bar of x is clear, that which is equals to xn, the derivative of xn will be equals to n xn minus 1. Okay, and the application of the same could be done as it is if x have some constant number plus b whole power n. So its derivation you can prove exactly in the same way, that power will be written in the start, ax plus b, power will be decreased by 1, and the derivative of the function could be there, and that is giving plus b whole power n minus 1 as a. This will be the answer, but you have to do it by the first principle. Make a practice of solving this question exactly in the same way. And if you understand my video, please subscribe at this point. Okay, Okay, next I will apply the same case on if the power is a negative integer, or in the negative integer you can say it's written like this, minus n. Okay, what will be the derivative of that one? First check that very easy case. If you are solving derivative of 1 over x, how it can be solved? Just be focused here. It's so easy that mostly we are taking bringing that up, it will become negative 1 in the exponent. Apply the power rule, minus 1 in start, minus 1 minus 1 means power minus 1, and derivative of the function without power. So it will be equal to minus 1 x minus 2, that is equals to 1 minus 1, and x minus 2 will be changed to x square when we are bringing it down, and this is 1. So derivative of 1 over x changed to this one. In the same way, you can check derivative of 1 over x square will be equals to minus 2 over x cube. Continue in this process. You can derive a relationship for your own convenience, that derivative of x negative n or derivative of 1 over xn will be written in the form like xn is there, minus n over x power n plus 1. You can derive this relation, and every time when you have to take the derivative of a function which is written in the denominator and there is one only in the numerator, so write down the direct power rule like this and solve it. It's just a small tip, and it will make most of the question which are including these type of the function very easy for you to derive very quickly. Okay, so thank you so much. Allah Hafiz. Please don't forget to subscribe to my channel. Okay, thank you so much, and Allah Hafiz.